number 3, and then the rest time is going to be for you to practice some of these. Okay, so on page 4 of your packet, 5 of your packet. We are introducing Gay-Lussac's law. Okay, again, you don't need to know the names of these. However, in Gay-Lussac's law, we are looking at how pressure and temperature are related. Okay, so Boyle was pressure and volume using this formula. Charles was volume and temperature using this formula. And Gay-Lussac is now going to be pressure and temperature using that equation or formula. Okay, again, the 1s and the 2s are not mathematical. They just represent the pieces that belong together. So like your starting and your ending or things like that. Okay. So in Gay-Lussac's law, you can see that volume is not a variable. Okay, so we're going to assume constant volume. And it says at constant volume, the pressure of the gas increases as the temperature of the gas increases. They are directly related. Okay, so when one goes up, the other one also goes up. As you increase pressure, or as you increase temperature, you increase pressure. Here's an everyday example, and this will apply to you when you start driving and have your own vehicles. When you fill your tires, okay, you fill them with air at a certain pressure. Okay, your car will tell you what pressure you're to fill them to. A lot of tires or a lot of cars now have automatic pressure gauges on the tire, and when the tire pressure gets low, it's supposed to tell you you have a flat or there's something wrong. A light will come on. Some people who don't understand the way gases work think they have a flat tire or a hole in their tire when they really don't, and here's why. A lot of times in the transitional months where you might have a really hot day and then a cold night, like we can still get now, your temperatures can get really warm during the day and then cold at night. If you go to fill up your tires at a tire place and you fill it up to whatever the manufacturer's tire pressure says, and let's say you fill it up at 3 o'clock in the afternoon and it happens to be a day that's 80 degrees. Okay, you're going to fill it up to the desired pressure at 80 degrees. But then you park it in the garage overnight and the temperature drops down to 32. Okay, the temperature has decreased a whole lot. And the pressure in your tires is also going to decrease a whole lot. So you may wake up that morning, get in your car, turn it on, and boom, all of a sudden the lights are on saying you have a low tire pressure. Doesn't mean you have a flat. Okay, what it means is because it was really cold, the tire pressure dropped. Okay, so you may want to add a little more air just because you filled it when it was so warm out. Okay, so there's an application. Next time your tire light goes on, it could just be Gay-Lussac's law in action. Okay, here's another example of Gay-Lussac's law. So this is just to add heat so we can increase the temperature of the air. Okay, so what's happening is the pressure is increasing and is pulling in air. How would you get the egg back out? How would you get the egg back out? Put it in the freezer or the refrigerator, okay? So change the pressure by changing the temperature. All right, just like the other problems. Whoops, wrong way. You again will simply identify your variables and then plug them in there where they belong, okay? So In a rigid container, okay, when it says rigid container, that just means the volume is constant. You don't need to worry about it. A gas has a pressure of 1.3 atmospheres. So here is a P at 25 degrees Celsius. Here is a T. What is the pressure of the gas if it is heated to this T? Okay, we know that we are using Gay-Lussac's law because we have two P's and two T's. We have to match up what goes together. Okay, some problems are easier than others. This one's pretty straightforward because it says it's this pressure at this temperature. Sometimes you have to read through it a little bit and match things up. Okay, so you might have to think, what is my starting versus my ending, and try to figure out what goes together. Okay, but this is pretty straightforward. Before I plug this in, what do I need to do? I need to do some extra math here. Okay. Yes, so if you have Celsius, you must change it to Kelvin by adding 273. Okay, so that's your T1 and your T2 is going to be 318. Right? This is the most common mistake in gas laws, forgetting to change your temperature to Kelvin. Okay, it will be wrong if you don't change it. Yes.
Oh, what's that? I2?
That's a T.
Oh, sorry, I couldn't see.
Yeah, I kind of wrote over it.
Yeah.
Yeah, this is your T2 and this is your T1. Okay, so now we can plug them in. So P1 was 1.3, T1 was 298 equals P2, which is what we're trying to find. I'll just make that X, and 318. All right, mathematically, how do we solve this? What do we start with? Two fractions. Liam? Cross multiplication. Okay, so we're going to crisscross. 298 times X equals 1.3 times 318. To get X by itself, we have to undo this multiplication by dividing by 298. That goes away. How many sig figs should be in this answer? 2, okay. We don't even have to look at the temperature here and decide which of these we're going to use because we're at 2 anyway. So the answer would be 1.4. And if we solve for pressure, what is our unit? ATM. Okay, so remember, anytime you solve for pressure, it's atmospheres, volume is liters, and temperature will be in Kelvin when you solve. Okay, so if we had been solving for T here, our answer would have been in Kelvin. All right, any questions about that? All right, now we're going to practice. So I will open the class kick in just a moment, but it is my recommendation that you do them on paper first and then just type them in. Okay, so it's going to be the Boyle's Law problems on page 3, the Charles Law on page 4, and Gay-Lussac